Hello and welcome to your first installment of Chiandra Math. We're going to go ahead and get started with square roots. This is going to be more or less to get you guys going in the math frame of mind, warm up your brains, and get you dusted off from this summer. I hope everybody had a good summer. So first thing we're going to do is knock out a little vocabulary. The first three are going to be in our first lesson on radicals, and the last two down here are going to be in our third lesson on square roots. So let's go ahead and talk about the first three vocabulary words. Radical symbol is basically just a fancy word for the square root sign. It is used to represent the relationship between the side length of a square and the square root of its area, which is more or less just saying that if I have a square and I know that its area is 25, what's the square root of 25? 5 and 5. So the side lengths correspond to the area by being squared, and then the square root of the area is the side length. So the radicand is just a fancy word for the number underneath the square root, and the principal root is just that a square root has to be positive. So if you'll notice, every number that's underneath this square root or this radical sign is a positive value. Now, where do you see the negatives? Only in the front. So these are outside of the square root sign. So the first example that we have here is the square root of 32, and what I want to do with these when I know that I don't know what the square root sign is right off the bat, I want to do the factor tree. So I know that 32 is divisible by 2, and when I do that I get 16. Now some of y'all may notice that the square root of 16 is 4, and we'll end up with the quicker version of this. But let's go ahead and continue with the factor tree on the 16. So 16 is divisible by 2, which gives me 2 and 8. 8 is divisible by 2, which gives me 2 and 4. 4 is divisible by 2, which gives me 2 and 2. Now where I want to look is at the end of all of these little trees right here. So 2 times 2 times 2 times 2 times 2 gives me 32. So I can rewrite this as the square root of 1, 2, 3, 3, 4, 5, right? 1, 2, 3, 4, 5 twos. Okay, so what we don't see in front of the square root sign is this little bitty 2 on the square root. And what that guy means is that's how many of the same number I need to create a group that can escape from underneath the evil square root sign. So you have your 2 and your 2 here, and you have another pair right here. So these guys can pair up and leave the square root sign. But when they do that, one of them disappears. So, or they get merged together, however you want to look at it. So the 2 times 2 just becomes one of them, and then the other 2 times 2 here becomes 1, 2 as well. Well, what's left over here is this guy, and he just gets to stay all nice and lonely underneath the radical sign. So last thing I need to do is simplify here. What is 2 times 2? Gives me 4, and then the square root of 2. So if you put this in your calculator, both these two numbers here will give you the same value. All right, so here, when we have a multiplication sign in between two square roots, we can combine these using the operation that's given to us. Now, if you ever see a plus sign, this will not work. This only works with multiplication. If you'll notice, factor trees are all about multiplying, right? So the only thing that you can use, the only operation you can use in order to combine square roots is going to be multiplication or division. So the square root of 3 then is times the square root of 12 is really the same thing as 3 times 12 underneath the square root sign, which, what is 3 times 12? 36. And 36, again, to do the factor tree, is 6 times 6, which is why I can take out my pair of 6's and just get one value of 6. Alright, so this next slide here is a chance for you guys to try it out on your own, see if you understand what I just talked about. So go ahead and pause the video at this time and go ahead and try them out. Alright, so 48 has a factor tree of 2 and 24. 2 times 12, 2 times 6, and 2 times 3. So again, you want to look at the end of all your factor tree pieces, so your branches. So just put them out underneath, and you get the square root of 1, 2, 3, 4, and then also that 3. So again, we pair up. This guy is all alone, so he gets to stay underneath. And we get 2 times 2 times the square root of 3. Go ahead and reduce these. 2 times 2 is 4 with a leftover of square root of 3. And there's your final answer. The second one here is 5 times 20, which is the square root of 100. We all know the square root of 100 is 10, but the reason for that is I have 2 pairs of 10s. So the square root of 10 times 10 is 10. So this one here is worth noting because we have the multiplication sign in between two different radicals that seem a little bit hard to look at and navigate. So whenever we see this, we want to make sure that we keep the integers with the integers and then the square roots or the radicals with each other. So I still use the operation, but I keep them separated with the proper numbers here. So the multiplication of the two integers is 2 times 5. And then I have the square root of 12 times 20. So that gives me 10 times the square root of, let's see, 2 times 12 is 24, with a 0 on the end, gives me 240. So again, I want to do my factor tree here. 2, 12, 120. 2 and 60. 2 and 30. 2 and 15, and then 3 and 5. So again, look at the branches of your tree right here. Put them all underneath your new square root sign or your new radical. 1, 2, 3, 4, 1, 2, 3, 4, and then 3 and 5. So we have 2 pairs that get to escape the evil radical sign, and then these two guys here don't have any pairs, so they get stuck all alone. So you get 10 times 2 times 2 times the square root of 3 times 5. So you just go ahead and reduce. What's 2 times 10 is 20. 20 times 2 is 40. And then 3 times 5 gives me 15. And so here's my final answer. Alright, so this is going to be our last slide for this lesson. And as Ms. Larson likes to say, what the letters? Who put variables underneath these things? So really this is no different. What we want to do is just separate everything out. So if you remember from Algebra 1, the exponents up here just mean that's how many times you have the r multiplying into itself. So since it's a 4, I have the r multiplying to itself 4 times, and I have the s multiplying to itself 4 times. So if you look, come on, there you go. Alright, so R, R, S, and S. So all 4 of these guys get to come out, and we have 2 R's, 2 S's, and then what's left over is going to be the number 5. So R times R, remember, is R squared, and times s squared, and the square root of 5. So really this is just r squared, s squared, times the square root of 5. And what you can notice is that because of the 2, that's how many numbers I need before I can pull it out. So the 4, if I divide it by 2, gives me the 2. The 4 divided by 2 gives me this 2 right here. So if I were to use that method real quickly, on this one, I know that the number of x's coming out will be 3, and here the number of y's coming out will be 1. But let's go ahead and write them all out just to be safe. Alright, so 500 is 5 and 100. 100 is 10 and 10. Now, I notice that I have a pair here, so I can actually stop and just use these numbers as my branches. So, well, I don't guess it's not equal to, so let's not put that in there. So let's go ahead and rewrite it. The square root of 5 times 10 times 10 times x, 1, 2, 3, 4, 5, and 6. And then 1, 2 y's. Alright, so we have a pair of 10s, we have 3 pairs of x's, and 1 pair of y's. So 10 comes out, 1, 2, 3 x's come out, 1, 2, 3, and 1 pair of y's. So because I have 3 x's, oh, let's not forget what's left over, the 5. So we have 10x to the third and y times the square root of 5. And so this is going to be our final answer for this guy up here. So at this time, why don't you go ahead and take a moment to pause this, and let's try this one out before you see what the answer is. Alright, so for this one you're going to need a calculator, at least I am, because I'm not so good with these numbers here. So let's go ahead and take this 392, put it out to the side. I know because it's even I can divide it by 2, but what it is after that I have no idea. So 392 divided by 2 gives me 196. 196 again is even, so what that is I don't know. So I'm going to do divided by 2 again. Gives me 98. 98 divided by 2 I believe is going to be 49, since it's really close to 100. And 49 I know is 7 and 7. So let me take my branches right here, set them out to the side. Again, this isn't equal, so let's just go ahead and rewrite the problem. The square root of 2 times 2 times 2 times 7 and 7. Then I have 7 a's. You really don't need to write them out, but I will just for you. Now the thing about this is, if you look at the 7, the closest even number I can divide it by is 6. So I know I'm going to be able to take 3 pairs out. Let me see, 1, 2, 3, 4, 5, 6, and 7. And then I take my b's, 1, 2, 3, 4, 5. And again, group up my pairs. So I got the 2's, got the 7's, got 1, 2, 3 a's, 1, 2 b's. So it's worth noting I have an a left over, a b left over, and a 2 left over underneath the square root sign this time. So got a 2 times a 7. Have 1, 2, 3 a's and 2 b's. And if you want to know where they all came from or went to, 1, there you go. Okay, just like that. And then what's left over is going to be the 2, the a, and the b. So now all we have to do is simplify. So 2 times 7 is 14. 1, 2, 3 a's gives me a third exponent with 2 b's, and then the leftover piece of 2ab. So if you can manage to do that, you will be good to go tomorrow. So I look forward to seeing everybody.